Okay, so I want to do 9.1 number 42, which starts with this equation. It has k sine t equals t squared. And then it tells me to explain some stuff. So 1, why must t be between minus root k and root k? What if you try to solve, like, if you rearrange this a little bit, right? Like, multiply by 1 over k, say, you would get sine of t is t squared over k, right?
Yeah.
Okay, so where is that output of a sine function live?
Where t is squared is inverse of the root of k.
Yeah.
Johanna? Where does sine live? Like, where's the output of a sine function live?
Between 0 and
Between 0 and
Yeah.
5.
2 pi.
Between 0 and 5.
Between 0 and 2
Between negative 1 and 1?
That's the bit I wanted. So sine, right, looks like this.
Oh, you said the outputs.
Yeah, the outputs of sine.
Oh.
So the outputs of sine live in this band, right?
Yeah.
That's between minus 1 and 1.
Well, if you said range, it would have understood.
So,
He said output, which is the
I know.
so what I know is that I know t squared over k has to be bigger than minus 1 and smaller than positive 1, right?
Yeah.
Yeah.
So if you multiply everything by k, you get minus k has to be smaller than t squared, has to be smaller than k.
Well, there it is. Then square root it.
And then you square root everything, and that gets a little weird. The square root's not defined for negative things, right?
So the negative square root.
So you just assume k is positive, right?
Mhm.
And then t squared has to be bigger than 0, obviously, because it's something squared. Okay, see that?
Yes.
And then when you square root both sides, or all 3 bits, it kind of makes sense. So you get 0 is smaller than t is smaller than the square root of k. But I
Which is
should
a plus or
really
minus.
think about the plus or minus part of this,
Well, that makes sense then.
right? But it doesn't make any sense to say it's smaller than minus root k.
Yeah, exactly.
So another way we could think is we could graph this, right? So t squared looks like a parabola, yeah?
Yep.
And that the heights coming out of that parabola have to live between k and 0, right?
And then the opposite of whatever k.
So those inputs are going to be down here, from square root of k to minus square root of k.
Cool.
Okay.
I just, what I did is I square rooted both sides in the beginning, and then I took a square root of both sides in the beginning, and I separated, like in the very beginning of the equation. Yeah. And then I separated the k and the sine of t,
Oh, sure.
and then I found that the square root of k equals the other side, so.
Yeah, that's nice. So another way you could do this is you could just hit both sides with the square root, right? Really, you should hit both sides, I guess, with plus or minus the square root, right? So you get plus or minus the square root of k times the square root of sine of t is t, right? And then you could divide that over, so you get square root of sine of t is t over plus or minus the square root of k. And then you could have this same thought with like, okay, well if I take the things between minus 1 and 1, square root them, I'll get things between minus 1 and 1. Well, yeah, except you kind of won't, right? Because you can't square root the negative bits. I would have stayed away from this approach because this part here doesn't always make sense. And you're kind of introducing some problems, maybe.
Yeah, I was just, like,
But that's a good thought, for sure.
I got there, and I divided the sine from the left side to the right side, so that the
Oh,
square root of k equals t over the square root. So I knew that no matter what, it would have to be, like, it would have to be equal to either plus or minus the square root of k.
yeah, okay. I'm down with that approach. You're playing a little bit fast and loose anywhere by square rooting sine of t. 'Cause that's not always defined, right? So you could have gone from an equation that had some solutions to an equation that looked like you needed the complex numbers to solve it. It's a good thought, for sure. I would, part of the moral of the trig chapters in here should be that you want to be a little bit careful when you apply something to both sides if it's not actually like an inverse function, if it's just like an inverse idea, like the square root or like arc signing both sides or arc tangenting both sides, like you can make some weirdness happen with those. Another good thought you could have that doesn't work with this problem because there's two variables, you could graph that thing and like just check the number of solutions that you're going to get. Does that make sense? And then they get me some like, okay, so I'm supposed to approximate solutions when k is 2. That's a great spot for a graphing calculator, right? Okay, see that? So into a graphing calculator, you would toss 2 sine t and t squared. Alternatively, you could like try to draw a picture on your own. So if you try to draw a picture on your own, you'd be
Are
like,
coefficients on the outside of a trigonometric function, can you put them as exponents on the end of the thing that you're applying your trigonometric functions?
oh, you mean can you like pull the 2 up in there? That's all. That works
Log.
with
Log,
logs,
that's what I was
but
like,
not
like,
with
what
sines.
is that from? Yeah.
Yeah. So for this one, right, I've graphed t squared. That looks like this. What does sine t times 2 look like?
Well, it's like a wave function with its amplitude double.
Yeah. Okay, so looks maybe like this, give or take.
Your peaks are at 2.
And then I don't know if this is tall enough to hit that or not. I wouldn't be surprised if it was, but I also wouldn't be surprised if it wasn't. Okay.
Good. No expectations.
Low expectations, yeah. So I'm expecting
But I really don't know.
2 or maybe 3 solutions. I'm pretty sure there's 2.
With 2 sides of it equal.
And then we could use a calculator to find them exactly. Or, sorry, approximately. Right?
Angle squared.
Let's see. Explain why this equation has more solutions for larger values of k. So why would there be more solutions if there were larger values of k?
Because then your amplitude would be really big, so that, yeah, exactly. Those would hit.
Right? If you stretch out that sine wave, keeping the t squared part the same, eventually, right, like there's some little hump over here. If I stretch that thing out enough, eventually that little bump will cross that parabola at some point.
Right.
And then if I stretch it out a little more, it'll cross twice.
Because as you approach infinity, the parabola will eventually go all across the domain of x, right?
Yeah, kind of if you thought about stretching infinitely, yeah, the parabola becomes basically flat, right, in that case. Of course, stretching infinitely doesn't make any sense, because, like,
But as
this
we-
is an equation in this class, right? Whereas this is not an equation in this class, right?
Yeah.
Okay, so this one would be a little problematic, but yeah, as you kind of
You're saying as
send k bigger, yeah.
As k approaches infinity, the amount of solutions approaches infinity.
Yes. Yep. Let's see, and then D, approximate the least value of k, if any, for which the equation has a negative solution. Oh, so when does this happen the first time?
At the origin. No, I don't know what the question was.
Okay, how about where's that bump? Where's the top of that bump?
At pi over 2.
Negative 5.
Negative pi. Oh, that one is at like.
Yeah,
negative
so
pi.
not this, but the
So
first
negative
peak,
pi?
right? So the
Wait.
first trough is at minus pi over 2.
Negative pi.
That's at negative pi. And so the height of the bump
Negative
is
3
at
pi over 2.
negative 3 pi over 2. Right? So I want to know when does that hit the parabola, right? So if I look at the parabola here, what's over negative 3 pi over 2 on the parabola?
That.
A point that's negative 3 pi over 2, comma,
Whatever.
something,
Whatever,
y something.
Oh, it's
But it's a
squared.
point on the
Squared.
graph, so it's a-
squared. So it's 9 pi over 4.
Close. 9 pi squared over 4,
Right.
right? And so my guess is that at the very least, if I stretched it up 9 pi squared over 4, I would hit, for sure,
That's true.
right? So some value smaller than that would work, and I could use a graphing calculator to like start guessing, right? But this would be a kind of a good first blow, because it's someplace around there.
Is this gonna be on the test?
That's a valid question for the test, yeah. I would probably not phrase quite that many chunks on an exam, but I'm asking you any one of those pieces might be valid. Like, use a graphing calculator to solve this. Would it, like, use a graphing calculator to solve when k is 2? That's a very valid question.
You got me. So when K is 2. Oh, when K is 2.
Like, solve this, in other words, solve this with a graphing calculator is a totally reasonable question for the test. And also probably pretty easy. Cool. Questions, thanks.